All right, welcome. This is the second talk in this session. This is Andy MacKelfresh from Duke University. He's going to be talking about the SC2i project, Surgical Critical Care Initiative, leveraging iRods to accomplish multi-site data collection, harmonization, and analytics to generate clinical decision support tools.
Okay, thank you very much. And some of the slides later, the more technical slides, are contributed by Justin James, so I list him here as a contributor. Just real quick before I dive in, about myself, I did a computer science degree as an undergraduate, and so I spent, 5 years in a dark room listening to electronic dance music, writing thousands of lines of code. So I've made my bones as a programmer. And then later in my career, I decided to go the business route and organize people to bring them together to create solutions. Or at least that's what I remember. You'll have to prove to me that it actually existed and I just didn't wake up today and it was plugged into my brain like the Matrix. A little bit of the travel makes me feel like, who am I? Where am I? Is that all real or am I just here in some kind of robot? So just preparing myself for Amsterdam this weekend. As a quick disclaimer, you're going to hear a little bit about military stuff. So this project is funded by the United States military. Okay, so quickly on how this project is funded. It comes out of the Department of Defense. It's not just about improving the military outcomes. There's also civilian applications, so it also improves the outcomes for you and I and other people. And as such, you can see on the left side of this diagram, there are a number of military organizations that contribute to this. The other organizations that contribute, we work with Emory University in Atlanta, Georgia, as well as Duke University. And then, of course, RENCI is our partner on the development. Let's see, what else should I say here? And then the goal is to create these CDSTs, so clinical decision support tools. And what these are is that they aid the physicians in administering treatment to people with critical injuries. So boiling this down into what we're actually trying to solve here. So the problem is management of these very severe or trauma surgical patients, both military and civilian. And the solution is to give these decision support tools. In the past, a lot of this has been visually guided. So if someone, if you want to talk about military, let's say there's a roadside bomb, and someone's leg is blown off. In the civilian section, maybe it's a really bad car accident, right? And there's a huge gaping wound. Historically, the surgeons would see these things and use their eyes to say, what should I do to address this thing right now? What we're doing is we're digging deeper into the omics type data of what we can draw out of the patients in order to serve up helpful information to the surgeons in those cases so that they make the proper decision and then the outcomes are better. Okay. Another kind of high-level slide here is, so on the very left is the patient. We have a event like time-based protocol, so we collect data at time points, and then it's run through all of these different types of assays, right? So serum, we draw blood, then we run all of these tests, and then we get these outputs and expressions and things, okay? They look at the tissue, and they can draw information from the tissue. And the effluent's actually the liquid that comes out of the things, okay? So that all gets run through these numbers of assays and produces results. These results can then be data mined, right? So we can track, okay, a person may develop a blood infection, and what are the biomarkers in all of that data that would tell you, okay, this patient's getting a blood infection. And so we're doing machine learning and things like this to track and say, okay, we can now see that pattern, and then we can run these tests and then help the physician by saying, hey, look, he's unresponsive, he's intubated with a tube down his throat, but based on these results, it looks like he's developing sepsis, so you better go ahead and tackle that. And then overall, this is like everything in one slide, so some of this probably you can ignore. On the very far left is the biobank, so they store. We have to put in technologies to help them figure out what they have available to run through these machines. On the very right are kind of the metadata and these things that I talked about, machine learning, and they're doing methods, effectiveness studies, things like this. And then starting to drill down, and now we're going to start getting closer to the technology, is that all this data comes in, gets put into that green box in the middle, which is the AWS, the Amazon Web Services Cloud. And then this is where we manage the data, and I'm going to tell you how we do that, and put it out for their designing and analysis. Then they do a lot of improvement on that. So they run it through, they say what worked, what didn't work, what can we do better, and then so there's constantly cycling and improving this thing. I mean, overall, the number of subjects we have, the number of data points, it just basically ends up being a huge matrix of data, sort of like a data lake, but it's very structured. I think there's 60 million data elements right now, something like that. So it's a ton of data. Yeah, and then these are the products that are coming out. Appendectomy, Woundex, pneumonia, bacteremia, severe traumatic brain injury, acute kidneys things like this. These are all the things that we're trying to improve. Okay, so here's the technology. We are in the Gov Cloud, which is a special area of Amazon Web Services. Supposedly it's buried under the ground somewhere in the western United States, but nobody will tell us where. And that's only the primary data center. The backup data center is somewhere else, who knows where. So we are under the ground somewhere in the United States, but we have iRods in there, right? So iRods is buried somewhere. It's a pretty simple structure in the sense that, so we have some tools out there, we have a firewall, but we have iRods, and then the ETL, extract, transform, load, which I'll tell you about the stuff we do in iRods to get the data in and out. We also have a relational database, so we use Postgres. One of the people from RINC does the network and security and so forth, so we have a firewall and then a ton of security controls. And behind that is the scalable storage, and then we connect outwards, if you see all the way to the right, to the Duke Identity Management System, and I'll tell you a little bit about that, how we do like a single sign-on type thing. So the RINC team does a very good job with implementing this and supporting this. We've been working on this since 2015, something like that, right, Justin? Yeah. Or at least that's what my brain told me. Okay, so how about some technical stuff? So for authentication, we use something called Shibboleth. I don't know if you've heard of Shibboleth, but it's like the newer age single sign-on type thing. Once they're authenticated in Shibboleth, so they log into the Shibboleth system, there's some automation that occurs, connecting over to iRods for connecting and, creating the user accounts. Behind that, we use this tool called Grouper. So it's not just about having an account, but it's about what you have access to. So, when the user logs into Cloud Browser, which is the interface for iRods, the groups are created automatically or updated if the permissions have changed. And some examples of how we manage those groups, we have studies, we have sites, we also have some secure folders. So there's a number of permutations that can occur. One person can have access to this and that, and the other one to that and this. And, the way it plays out, actually jumping all the way down to the bottom, is that we have a specific group that's created for every permutation, right? So on the grouper side of thing, on the human management side, I might go in and click, this person should have access to this and this, but the automation that occurs with the connection to iRods is that these groups get boiled down into these kind of combination type things that hit all the options. Authorization requires access. And then the combinations. Okay, we hit all that information. Yeah, and this is sort of the workflow, so I lost my screen here. Look over here. So this is sort of like a maze, but the number one is down in the middle. The user says, okay, I want to log in, and then immediately Cloud Browser goes and connects over to the Duke Shibboleth thing and says, it gets redirected. So they get redirected to a login page over there in the Duke Identity Management System. And then the user puts in their credentials, is number 3. And number 4, that goes back over to iRods, and it does these things with the groups, Number 5 is the user gets created if it's their first time logging in. Number 6 is that the groups get modified if they need to be based on access changes. And then number 7, they get let in. So that's kind of the workflow of how it all works and that integration with the single sign-on. Whoops, did I go by one? No, rules. So yes, we use the Python rules engine, and again, this is Justin who's implemented this, but we had to use the intelligence of our rods to help us manage all this data. And so here are some of the things that we leverage those rules for, which is to determine if the files are of interest, or basically, are they in the correct format? Should they be there? Should they be loaded into the system? There's some validation of those files that occur. We have some like batch jobs that are running to have a periodic delay and determining if a new output from the system is required, and then some policy enforcement points for logging and auditing down the road. And then we also leverage the metadata. So, the validation of the status of the input files. So, if you can imagine, we're getting these data files from sites. We need to be able to tell them, did it work or did it not work, and leverage the metadata for storing that and then being able to report on that. The dates and the times of the submissions and the output generations, as well as the progress that's occurring right now. Okay. So I know I breezed over those things pretty quickly and read those bullets. If you have questions, I'm sure we can answer them, and probably Justin will answer them if you need a deeper dive on how those are implemented. So at the end of the day, we get all this data together, we pump it out into one big flat file. It's like the major rabbit hole, all this data just trickles down, and sometimes you're just not even sure what's going on behind all the scenes, but it all comes out pretty good and magically, and it's been a great project, and we are really advancing, the treatments for critical care, so doing good in the world also with this stuff, so it's a good use case to show how iRods is used in different ways, and this is just one of them. So I'm all done with my slides, but I'm happy to answer any questions.
Coming around.
Yeah.
All right, heads up.
I don't have any yaks. I shaved them all.
Thank you so much for the presentation. I missed beginning of your talk, so I'm sorry if I ask these obvious questions.
No problem.
What's the size of your data set?
60 million data elements.
In terms of bytes?
I don't know.
Okay, I saw that you use elastic block storage.
Correct.
And currently, if I am not mistaken, EBS volumes have a limitation in 16 terabytes. It's a limitation by Amazon Cloud.
Yeah.
So I wonder if you could use elastic file system instead, because this storage may be not that fast as EBS, but it has no limitations practically.
That's a good suggestion. Would you like to speak about this one? I mean, the data isn't as big, bulky in data as much as like number of data element, like it's numbers, it's
you
all
keep
numbers.
all your data in single file?
No. A relational database.
But it should be definitely less than 16 terabytes.
So there are a ton of different input files, but we're nowhere near the point where we'd have to worry about something like that right now. If we did get to that point, then we could move our storage to something different. But I don't see that happening anytime soon.
Yeah, and of course
So-
you could attach multiple EBS volumes to same EC2 instance, but
Right.
I suggest you consider at some point EFS
Right.
instead.
But right now it's a pretty, there's a lot of data per patient, and quite a few patients, but it's not, it's not anywhere near probably what a lot of you are used to as far as the amount of bytes that we use.
I see.
So it's mostly the rules and there's a lot of support structure around iRods too to support decision making and things like that. But
Your implementation of single sign-on system for iRods, this is great. I would love to learn more about this.
Right, okay. Yeah, I can let you know more
Yeah,
about it.
thanks.
Thank you very much.